In this video, let's have a discussion concerning experience, human intelligence in design intent for an object. And so the original designer posted a question on the internet about could these 13 slots be patterned? And the response from experienced users was that they would do it exactly the way he did it. So let's look at how the original designer did this. And so I'm going to edit the first sketch. And the first thing that I notice immediately is that there's no lock symbol on the sketch indicating that it is fully defined in a parametric software. And I also notice that there are numerous blue curves and white dots, so color is another way that different parametric CAD programs, design programs, indicate whether a sketch is fully defined or not. Remember that this was a cylindrical object, so to measure the outside diameter with calipers, you would measure the diameter. To measure the hole, you would measure the inside diameter. You can't really measure the radius to the imaginary center of the hole. So it would make logical sense then to dimension in the same way that you would measure that. So rather than giving the dimension as a radius, I would give it as a diameter. So I would start out with a center line and then give that diametral dimension for the hole, the overall diametral dimension for the outside diameter, and so on. And then we look at this dimension, this 1 inch dimension from here to here is an aligned dimension. It is not a horizontal dimension, and it's not a curve length dimension. You know, if you took that length of that curve along 1 inch, it's not a curve length dimension. It is an aligned dimension. So you have to wonder, is that the true design intent, or is the true design intent for it to be a horizontal distance from here over to here? If we look at this first slot, we see that these two lines are not vertical and this one is not horizontal. But if you look at all the other slots, the sketch has a horizontal and vertical constraints for those lines. So why is this one slot different from all of the other slots? Now maybe the design intent is for those slots to go along the curve, but the other slots don't match that design intent. It becomes rather obvious that it was a beginning user who really didn't understand the implications of what they were doing. We'll also notice that some of these dimensions are aligned dimensions and some of them are horizontal dimensions, so they don't follow a logical pattern of all being duplications of the same pattern. And then this distance, if they call this the beginning of the slot going from left to right, and it's the end of the slot, this is 0.227 from the end of the slot to beginning of the slot, but the next one is from beginning of slot to beginning, beginning to beginning, so forth. So those all match a pattern where this distance doesn't match a pattern. So that looks like an oversight to me. And if an expert user did not observe that when trying to help a beginner, I have to wonder how artificial intelligence is going to look at this and say, you know, this doesn't make logical sense, and let's offer a different possibility for a solution. And then how is that beginner, though, going to pick from a range of possible solutions? This is going to be interesting as the technology goes forward to measure artificial intelligence against real human intelligence, particularly when we see that real human intelligence from an expert user also doesn't catch some illogical dimensions in a design. As I continue further with this, I see that, or I observe that these curves are splines. I can tell that by the handles on the end of them. Splines are a more complicated geometry. I did a single 3-point arc from here over to here up to this given point here, and that arc closely matched that spline. If the greatest distance was somewhere over in here, the discrepancy was 1/1000th of an inch. That would be even difficult to measure, let alone hold that tolerance in manufacturing. So I suspect that we can replace these splines with a simple 3-point arc. So let's look at my solution. So first of all, I drew a center line, or sketched a center line, a horizontal center line, and then I sketched a vertical construction line and dimensioned that as a diametral dimension immediately. So it turns black I have a lock symbol over here indicating that line is fully defined. I then drew a second line and the same thing. I dimensioned it diametrically immediately. I put in my construction line over here. I did my line over here, put the dimensions in, drew my 3-point arc. So this point is coincident with this line. Drew my arc across here. Now, the question was what to do here then where there was also a spline here. Let's try a 3-point arc and see how that looks. I'll do a 3-point arc from this point over to about here, and we'll go ahead and create that arc, and then we'll add a tangent constraint between here and here. Now we don't really know, obviously the beginning designer was a beginner with little experience, and so we don't really know what the original object was, but I'm going to go with that as maybe the true design intent. And then I'm going to draw a line out here in space. So the original question is, can we pattern those slots? So I'm going to put a line out here in space someplace, and then I'm going to draw a line tangent to this arc to this point up here. So I'll draw this line. I'm going to click and hold my mouse button down. When I click and hold it, it's automatically going to put a tangent constraint to that arc. And I'll come up here and I'll select the end of this line. I'm going to change this to construction line. And for now, I'm going to go ahead and change that to construction line as well. I want to put a horizontal constraint on this line. So I'll do horizontal. And it gave me an error. Let's go in and see, but it did put it in there, so it solved that issue itself. So I have the tangent to the high point on the arc. That'll be the highest point because this line is horizontal on that arc. And then I'm going to dimension the distance from here over to the beginning, and maybe I should have put that dimension in before I put in the tangent, but I'll dimension from here over to here. And let me try that again. I'm on the line command. I need to be on dimension from this point over to this point, and I want that horizontal distance of 1 inch. So this line turns black, but I still have an endpoint here that is white. An unconstrained endpoint could be dragged to any length. So I'm going to put a coincident constraint between this center line, and I'll hold down the shift key and the midpoint of this line. And so now it's fully defined. The length of that line is fully defined as tangent to the arc, that height. And we don't need any more dimensions on here. We see over here the lock symbol that it's fully constrained. Let's go ahead and finish the sketch, and we'll revolve our beginning geometry. And so we see here is the geometry before we cut any slots into the solid body. And I want to offset this down, and I'm a little bit concerned about what this line is right here. So I try to investigate why this circle between these two faces existed. So I'll go back to my sketch and I'll edit my sketch, and I'm going to zoom in here. When I was creating this dimension, I accidentally put a line in here, and so let's delete that line, and then we'll finish this. And so that's what it was. I made a little mistake in here. So as we're going along, we have to observe what we're doing, because if I call myself an expert, then I make a mistake myself. I have to be able to identify those mistakes. And sometimes you just have to give it to somebody else. You can't see your own mistakes. Even the highest paid author in the world has an editor to review her work. And in this case, I was able to find my own mistake and fix that mistake, and find them as you're going along. So observation is a key. I'm going to offset this surface, so I'll go to the surface tools. Now, not many people know about the surface tools or where they might be valuable. They tend to think that the surface tools are only for highly organic shapes, but they can also be used for basic shapes. So I'm going to do an offset, and I'm going to select this surface. And it probably starts out as a chain selection, but I don't want to select this surface. So I'm going to uncheck chain surface. I want to keep this as simple as possible for computational purposes on the computer. I'll control unselect that. If I had this unselected from the beginning, it wouldn't have selected that face as well. I'm going to go in, and I'm going to go in negative 0.03 as my offset distance. Now right now we can't see that surface, but if I come around here and look at the end of it, we can see the edge of it buried inside of our solid object. Let's turn off the visibility of our solid object. And there we see the surface body. It has no mass. It's infinitely thin, but we can use it as construction geometry. I'm going to go to the surface body and I'm going to go to the opacity control and I'm going to set it almost transparent. So I'll do 10%. So it's visible, but it's very, very visible. In fact, I'm not sure on the recording I can see it. I'm not sure how well you can see it on your screen. We don't even really need to be able to see it as long as we can select it over here from the browser. I'm then going to edit that sketch, and we could have done this originally, but I'm going to edit that sketch and I'll go in here and I'm going to change that construction line to an object line. So I'll change this to a normal object line. And the only difference is if before when we did that revolve, we would have had to pick this area and this area as 2 steps rather than as 1 step. But I just wanted to keep that simple when we did that revolve. And I'll finish this sketch now, and I'm going to do an extruded surface. So I'll select this extrusion, I'll select the line, and I'll tell it that I want to go symmetric, a total distance, let's say, of 2 inches. Now we just need to make sure it goes all the way through our solid body. Now if we want to make this parametric so that if we make a change in the future, we could come up with some parameter. For example, dimension the length of this line as a reference dimension, and then use that reference dimension for our distance for the extrusion. I'll go ahead and say OK to that. And then I want to pattern this. We'll hide the sketch. I want to pattern this as 13 copies. So I'll go into a pattern and I'll do a rectangular pattern. And I have a choice of selecting bodies or features. I prefer to select the most basic geometry. The bodies is actually more simple than the features, and I'll select bodies. And for the axis, I could select the center line from the original sketch, but that center line could be deleted. I prefer to select the z-axis, which can't be deleted. And I need to select this body first, though I thought I had selected it. I want to pattern this extruded surface, so I'm going to go in and I'll do pattern, rectangular pattern. And I'm going to set it, I want to pattern this surface body. So I'll put it on bodies and I'll select the object. I want to pattern this object. And then for the axis, I'm going to select the z-axis. Now I could pick the center line of the first sketch, but that center line could be deleted where the z-axis can't be deleted. So I prefer to select that z-axis. I'll do 13 copies, and then I want to do a distance of 0.227, and so we see that the 13 copies come out. Make sure that it's on spacing, not extant, and then I'll say OK to that. And so I have my 13 copies of that extruded surface. I'm going to go around to the top view. Now it might not be real apparent here, but because I turned the transparency or made that the offset surfaces, remember the offset surface is inside the solid body. I want to make sure that I get just these extruded surfaces, and so I don't want to get this surface right here when I do my trimming. And so to do my trimming, then I need to trim a circle in each one of these surfaces. So I'm going to rotate it around where I can see these fairly clearly, and then I'm going to do a trim. I'm asked to select a trimming tool. I'll select the offset surface, and then I will select these holes in the center. So I want to trim this circle. Notice it turns red. Now it's going to be a little less obvious, but we have to make sure we get that hole. We don't want to get this outside or it will delete that. So we're getting what we want to delete. We want to delete that hole on the inside, the circle. And if we make a mistake, we can edit that, so we could go back and edit that feature. So I'll do edit feature, and if we selected the wrong thing, we could control select to unselect the wrong thing and then go back and get the right object that we want to get. In this case, I want those circles in the middle, so that one's will get a little bit hard to select. And if we find a location where they tend to select more easily than other locations, and so up near this top, I'm able to select those. I'll say OK to that. Then I want to look down through the middle, make sure that I got all of those surfaces trimmed out. So I have those, and so I'll say OK to that. Okay, so I have my pattern surfaces. I'm now going to turn the visibility of the solid body back on. I don't need that offset surface visible, so I'll hide the visibility of that. And I want to be able to select these surfaces all at once, so it's hard to select them from here, although I could use a window selection from left to right, or I could select them from the top view. I could use a crossing window or a window selection from the top view, either way. And I'll do a thicken. And I want to go 0.04, and I want to do a cut so that it cuts those slots into my original solid body. Okay, so we see the slots. Now I'm going to add a fillet here on the end, and the original design had a larger fillet here, a smaller fillet here. You can stick with that design, but I'm just going to show something different just for the purpose of showing something different. I'm going to do a full round fillet. I'm going to select this end face, and I'll say OK to that, and that puts a single fillet that goes all the way around. Even if I change the diameter of the hole or the outside diameter, it will automatically go around. Now that was just a design change that I made just to show the possibilities. But let's go back to the original question. And the original question is, can we pattern these slots? The answer is yes, you can pattern, but the answer the user got was the expert users would do it the same way the inexperienced user did it, with illogical dimensions, with illogical distances between the slots. Just makes you wonder, what will artificial intelligence do when we get to that stage in the development of technology? Will it offer us solutions that make logical sense? But how will we select the optimal solution from a group of solutions if we don't have experience